Let's talk about query federation. If you work with data on a regular basis, odds are that you have to deal with data in different places at least some of the time. And it's also pretty likely that you're trying to answer questions with that data altogether. And so the fact that they are in different places can be pretty inconvenient. Data being in different places. So this might look as simple as maybe you have a folder of CSVs with historical sales transactions, and someone has just emailed you an Excel file with the latest data, and you want to compare all of them. Or maybe you have a production database in Postgres recording web activity, and also a Snowflake data warehouse for your more historical analytics. And maybe then someone has just emailed you an Excel file with the latest data, and you want to compare all of them. Or maybe your setup has like Databricks and a Delta Lake, and you need to combine that with a bunch of Parquet files on S3 and also some JSON from a REST API. And then maybe someone has also just emailed you an Excel file, and you want to compare all of them. Okay, so I'm kind of joking about the Excel file, but only kind of. The point is that if you're trying to answer questions with the data, it can be frustrating to not be able to query your data altogether just because they're in different places or formats. You can do things like set up data ingestion to move your data around, but that's going to carry a whole bunch of complexity, maintenance, and financial costs with it. If you do that, you're probably also going to need things like scheduling and monitoring and testing. Sometimes you might want that infrastructure, but you shouldn't need that infrastructure just for the sake of asking questions of all of your data. It's a bit like going into your kitchen expecting to cook a stir fry with the ingredients that you already have, and then being dismayed to learn that you actually first need to go out and pick up all of the ingredients from 3 different stores. And also, you need to buy a car and build a road first. So this brings us to query federation. Query federation lets you access, analyze, and generally join your data from multiple sources within a single query. Instead of needing to do a bunch of pre-work and set up a bunch of infrastructure to get all of the data in the same place, query federation lets you treat your data like it's already in the same place. To go back to the cooking analogy, it's like getting to your kitchen, realizing you don't have the ingredients you need for your stir fry, and then getting to use a magic portal to get the ingredients you need, instead of driving to the store and doing all of the work that might come with that. Okay, so before we close out, let's take a quick look at query federation in action using GlareDB for this example. Imagine you're analyzing some sales data. You want to know what are the top 5 products by total sales amount, and what are their average customer satisfaction scores. The catch? Your transaction history is in Postgres, survey responses are in Parquet files on S3, and your product details are in Snowflake. Luckily, that's not a problem when you can use query federation. So in this example, I'm going to be writing SQL using the GlareDB Python bindings. You could also do this with the GlareDB CLI or the Cloud SQL workspace. The first thing we're going to do is import GlareDB and set up our connection, which is going to let us write queries. Once you have your connection, you can just start writing your queries. So this query is pretty big. I'm not going to go into too much detail, but the main idea is that we're able to join from our different data sources. We have our transactions table in Postgres, we have our products table in Snowflake, we have our survey data in Parquet on S3. We're able to join between them as though they're all within a single database, all just individual tables within that database. And so when we run this, we're going to output it and look at the results as a pandas data frame. We can get a sense of what our top 5, top 20 products are by total sales. We can also see the average satisfaction rating for each of those products and the total number of surveys for them. So that's all well and good. But now it's Friday afternoon, you think you have this query all buttoned up, and someone tells you that actually the Postgres table didn't have all the latest sales transactions. And here's an Excel file or maybe a CSV with purchases from an offline location. It's not a big deal. You can just download the file and treat it like any other table in your database. So in this case, we're able to just union our CSV transactions over here with our transactions in Postgres over here, wrap this in a CTE, and then we can just do the rest of our join exactly like we did before. When we run this, you'll see that our numbers have changed slightly. I don't think any of the categories have changed, but the numbers have changed. And so the way that you can treat Postgres, Parquet on S3, Snowflake, all as if they're individual tables in your database, you can do the exact same thing with just a local file as well. And that is the power of query federation. In just a few seconds, you can join data across totally disparate data sources as if they were in the same place. And you can do this in a Jupyter notebook, in a SQL-based environment, in your dbt pipelines. All you need is a browser or a terminal shell or just any environment where you can run Python. That's it. If you found this helpful, please like and subscribe, star us on GitHub, follow us in all the places. And if there are specific concepts you'd like explained or examples you want to see, you can just let us know in the comments. Thanks, everybody.